Hi everyone, in this video we're going to discuss our Ujian Pecutan Tengah. So our test here involving topic 1, topic 2 and topic 5. So for number 1, it is a topic 1 complex number. Given a complex number, express this complex number in the standard form or Cartesian form, where real part, this is imaginary part. Hence find your modulus of your complex number. So first of all, our complex number, we simplify it. You have a division on your complex number, which is 4i minus 5i squared. And I squared here is equals to negative 1. Therefore, we simplify this to be negative 1. Real part is 5. Imaginary part is 4i. So with this condition, division for complex number, the way to simplify it is multiply with its conjugate to rationalize the denominator become a real number. So the conjugate for the denominator complex number, it will be 5 minus 4i. We will exchange the sign for imaginary part from positive to negative. So complex number times with its conjugate, always we can get a squared plus b squared, which is real number value a squared and b value squared. So here 5 squared will give us 25 plus b, the value of b here is 4, 4 squared gives us 16. Then for the numerator will be expand like usual, 2 times 5 we get 10, 2 times 4 we get negative 8i, then 3 times 5 we get positive 15i, and then 3 times negative 4 we get negative 12i squared. Again, I squared simplified to be real number, which is negative 1. So now we simplify our numerator. For the real part, it will be 10 plus 12. It will be 22. For the imaginary part, it will be, so denominator 25 plus 16, which is 41. So this is our real part. Imaginary part, where negative 8i plus 15i, it gives us positive 7i over denominator here 41. So this is our complex number expressed in the standard form, where in the front here, first term is real part, second term is followed by the imaginary part. So after we get this standard form, the question asks us to find the modulus of the complex number. The modulus of the complex number is square root a squared plus b squared. So substitute in our a value, real part is 22 over 41 squared. Then substitute our b value here is 7 over 41 squared. So by using your calculator, you can express your answer in third form, which is 533 over 41, or if you want to express in decimal, make sure your decimal have 3 or more significant. So which is 0.5631. Alright, make sure you have enough significance for this decimal. So for this question, it is 5 marks. The first mark is how we simplify your complex number. That is a concept, and apply the concept for division complex number by multiply with its conjugate, then get it to the standard form. Then apply the formula for modulus complex number, get it to the answer. Alright, so we move on to the second questions, which is a log questions. When we doing the log questions, we need to make sure having the same base. That will be our first step to doing the log questions. So I have a log base of x and a log base of 5. to exchange this, we will maintain the base of the number instead of base of unknown. Alright, so then we can find our x more easier. So to solve this log equation means to find out what is your x. Change our base log, follow this base number which is 5. So log 5 over log 5x. So change this log in terms of the base 5. Numerator for the item 5, denominator for the base x. So when you have your log term in division, you can see your log is in division, which means that we cannot simplify anymore. We need to let your log to be n. So here log 5 equals to 1, it will be 9 over n equals to m. And we simplify this equation, we multiply up, m squared equals to 9. And this is your quadratic. So m squared minus 9 equals to 0. We rearrange and we do factorization. So we have m is equal to 3 and m equals to negative 3. Then we substitute back our m term. Actually, it is log 5x equals to 3. Then when you want to get your x, we just unlock the base 5, we go to the opposite and power. So that's why we will need our log in the base of the number. When you unlock, you just move your value to the opposite, you can get your x already. So 5 to the power of 3 is 125. And this one, 5 to the power of negative 3, simplify it, it will be 1 over 125. So for log term, remember to check the validity. 125, when I put into log term, log always can bring the value of positive only. So make sure the value that we find here, put in the log here, that it can be function. So this is valid. And this one is positive number. When you put in the log, it also gives us a valid log function. So here we have our answer. Then we see what is the important concept here. The first one is the concept of changing the base. Changing the correct base. Then you simplify, you can get a quadratic and factorize here. Quadratic to factorize here. Then you can get two answers of the n. Then we substitute back the log and unlog to get the value of n. So we have to get the value of x, we have to answer of the x here, which is valid. Alright, so that's all for this question A. We continue for question B. So for this question, they ask us to find the solution set for modulus. When we have modulus both sides, our method to solve this modulus inequalities both sides is by squaring both sides. So first of all, express the modulus in square root and square first. So symbol of modulus is equals to square root and square, expressly involved. Therefore, when you want to get out of this surd, we need to square both sides so that the square root and the square can be cancelled. Then you have x plus 4 squared and 2x minus 3 squared. So we have a quadratic here. Quadratic, we expand and rearrange, then we factorize. So here we have ax plus 16 more than equal 4x squared. And then, so how to expand this? It will be a squared plus 2ab plus b squared. Bear in mind, when you expand something from 2 terms, you will expand it to 3 terms. So 2a squared, 2 times a times b give us negative 12x, and then b squared we get 9. Then we rearrange it to the left hand side, we get negative 3x squared, and then plus 20x, then minus the 9, positive 7. Before we do factorization, make sure our quadratic is positive, so we divide by negative. And when you divide by negative, bear in mind inequalities need to change sign. So after we changing the sign, the quadratic is ready to factorize. So please follow the step in solving this. So factorize, we get x minus 7 and 3x plus 1. For solving quadratic inequalities, we can using graphical method. So left hand side value negative 1 over 3, the value smaller value at left hand side, bigger value at right hand side. And we have smaller than 0, which means you are finding the region under the x-axis, which is this is a region of negative. Above the x-axis, this is a region of positive. So finding this region negative, then we know that this is our answer. We put in inside solution where this is negative 3 less than equal our answer, the region of the answer, and less than equal 7. We got equal because our questions here provided we have equal, so we will just follow through for this quadratic. So in order to score this, what is its important concept for these 6 marks? First of all, the important concept that is you need to know that square modulus both sides, the way of solving it is squaring both sides. Alright, so that is the important concept, and how you expand it until you get a quadratic. Then you factorize it completely, you factorize it correctly, drawing the graph correctly and shape the region correctly, then you can get answer. So here we have our 6 marks. 1, 2, 3, 4, 5, 6. Alright, then we move on to the next question, which is our topic 5, function. Given here, function fx and gx are defined as a quadratic. This one just general, all the real number means this is general quadratic without restriction, without condition. Also, this is a general rational function without restriction, just the denominator cannot equals to 0, so x cannot equals to 1. General condition for the function. For the first one, to find G inverse. So bear in mind, G inverse, please we use the latest syllabus, which is composite method. To find your inverse, where G inverse will equals to x. Please no longer using your SPM method. Alright, so at this level, when we're asking you inverse function, means we want to exam you on composite method. It's not exam you on the previous knowledge. Alright, so we show up your composite method where substitute G inverse into the function of G can mapping you getting back the x. So we will substitute G inverse into the function of G here. So the x here, we will substitute it as G inverse. Here we have G inverse plus 1 over G inverse minus 1 equals to x. Then we figure out our G inverse. We move out our G inverse. Firstly, we cross multiply so that we have one layer equation only. We get out of this fraction. It will be x G inverse minus x. Then we gather back our G inverse term. This one we maintain at the left hand side. This G inverse, we move it to the left hand side, and this number we move it to the right hand side. Then you take out, factorize out your G inverse function, you get 1 minus x. So here we go, we have G inverse negative x minus 1 over 1 minus x. So when we get a rational function, bear in mind to write the condition here. Denominator cannot equals to 0. So denominator x here cannot equals to 1. So 1 minus x cannot equals to 0. Simplify x not equals to 1. Alright, so bear in mind always writing your rational function together with the denominator condition where it cannot equals to 0. Finding out the x value. Then you can see the question B, they are asking us to find the composite function f(g)(x). So for question B, to find the composite function f(g)(x), firstly substitute gx inside. Gx is x plus 1 over x minus 1. Then substitute this into the function of x, which means that this x is replaced by x plus 1 over x minus 1 squared. So replace this fraction in the place of the x here. So what do we need to do is simplify this into the simplest form. From 2 terms, we need to simplify until 1 term. Alright, so how to simplify it? We expand first. This is x squared plus 2x plus 1 over the denominator is x squared minus 2x plus 1 minus 1. Then we get same to the denominator so that we have 1 term. Instead of 2 terms, we simplify it into 1 term. Then for this term, denominator will be times with this. It will give you negative x squared, negative become positive 2x, then minus 1. So at numerator here, we try to simplify. We can see the term which can simplify. Plus 1 minus 1, x squared minus x squared. So lastly, we get our numerator remaining 2x plus 2x is 4x. Denominator is x squared minus 2x plus 1. And this x squared minus 2x plus 1 actually is come from x minus 1 squared. So bear in mind, we write here, when we meet a rational function, we always take out the condition from denominator where this x is not equals to 1. Denominator not equals to 0. Therefore, I will write x not equals to 1. So that will be our answer in the simplest form. Alright, in order to answer this question, we have 4 marks. So we have the concept that you must know. The first one, finding G inverse using composite method. So if you are using the wrong method, you will get all wrong. Alright, then we see how you get off of the denominator, how you expand it and rearrange it. Then you factorize, you simplify up, take up your G inverse and get to the G inverse function, get to the answer. Then secondly, for the part B is we see how you find your composite method. The first one, substitute correctly. Substitute your gx into the fx correctly. Then we see how you simplify, get it to the same denominator and you simplify to get your answer in the simplest form here. Alright. So we will continue for the last questions, which is question 4. Given here, our function is an exponential function where base is 2. Or we call it, this is our indices. The first one A. Show this one is one-to-one function and state its domain and range. To show it is one-to-one function, we can use fx1 equals to fx2. So 2x1 will equals to 2x2. When we have indices equation and we have a single indices here, the base are same, we can compare the power directly. Then we can get x1 equals to x2. To show this, we cannot stop our answer like this. We have to answer our question in sentence. So we must write it how you relate this result to the sentence. We must come up a conclusion saying that x1 equals to x2. So thus this function is one-to-one function. And in the question A here, they ask us to find domain. Domain for exponential DSLR. It is not a special case for exponential function, which means that the domain can accept any value of the x. It don't have any restriction. But for the range of the function, which is Kasra for the last part is E, which means our exponential is not cover the whole graph. It only covers some part of the graph. So when we close this exponential, the value outside here is 0, which means that it will start from the value 0 to the positive infinity, not included because the 0 here is your horizontal asymptote for your exponential graph. Alright, so that is our part A. Then part B, we're going to find out is F inverse. So again, finding F inverse using composite method where F inverse equals to X. Bear in mind, finding F inverse using composite method. So substitute F inverse into the function. So it will 2 to the power of F inverse. And how we find out this power? How we get down the power? Where this base of 2, we move it to the right hand side and we log it to the base 2. So the inverse function for exponential function will be a log function. And after we find this F inverse, they ask us to find what is your domain and range. Domain F inverse, we will refer to the range that I've done before this, which is 0 to infinity. And range for F inverse, we will refer to the domain from the function which is negative infinity to infinity. Then we move on. For the part C, where it is the part asking you to find the value of x, given that f inverse equals to 2 minus x. So now they're testing you again. What is your f composite f inverse? So f composite your f inverse, it will be equals to x. So this question we are solving, x is equals to 2 minus x. That's why you can see this is 2 marks. I collect back the x, I get 2x equals to 2, x is equals to 1. Lastly, we need to draw our function and inverse function on the same axis. Alright, so my graph here is at here. So I know that the range is going up. Now we need to see whether it is shooting to the right or shooting to the left. Then we need to see its power. Exponential power, which is positive, which means that it is shooting up to the right. To draw the function and the inverse function, we need to do reflection. Set up your x-axis, your y-axis, and your reflection axis is y equals to x. Alright, so we have a horizontal asymptote. This is the horizontal asymptote that you have to draw up because exponential characteristic is not just the graph. when the graph has asymptote, follow through, you must show up is horizontal asymptote value, which is y equals to 0. And when we shooting up, I meet a situation where student will do it randomly, shoot like this, or shoot the touch here. So which one is the correct graph? Where we must know, is it the graph is going beyond or going above reflection axis, or it will go under the reflection axis. Alright, so this one you need to test with your calculator. Take out your calculator and you put in your function. When you put your mode into the table mode and you put in the function as 2 to the power of alpha x, start. What is your starting point? So you want to test your graph at this side, whether your graph is going under the reflection axis or above the reflection axis. So we will focus here. We will start from the value of 0. Then ending, put your calculator ending value like just say value of 5. And step means upper Selang value there. So if you 0 to 5, if you step 1, it will be in your coordinate of 1, 2, 3, 4, 5. Right? If I step 0.5, I will get around 20 coordinates. Alright, so this is my calculator result. When I have x and y value from my calculator. 0, 0.5, 1, 1.5, then 2, 2.5, 3, 3.5, 4, 4.5, and 5 will be my last coordinate. You can notice that when I have 0, it get you 1, and your coordinate y is 1.4142. Then this is coordinate of 2. Then this is 2.8284. This is 4 and 5.65, 8, 11.3, 16, then 22.62, and 32. So how we see this coordinate? When you have reflection axis y equals to x here, means your x coordinate will be equals to y coordinate. This is your reflection axis. You see, when you have x0, your y coordinate will be at 0. When you have 0.5, it will be 0.5. When you have 1, 1, 1.21, 1.55, 2, then 2.5. And you see your graph. This is your curve. This is your reflection axis. Ini pasti pantulan. Nilai pasti pantulan. Nilai pasti pantulan 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Alright? This is the coordinate you will get. And then you see your curve. You see your curve start from beginning here 0. It will be greater than your reflection axis every time. For every point, getting more to the right, for the whole graph, it is getting more and more bigger value than your reflection axis. What does it mean? It means that your graph is going shooting up and up and up and up and up. So that's why you can see from the beginning it just differs a bit, but at the end you can difference a lot. Means your graph is going more higher than your reflection axis. So that will be your correct function. The curve of the function for exponential. So it is shooting to the right, but it is not go under the refraction axis. That only the correct shape for our exponential function. And what is the intersection point? When x equals to 0, intersection point is 1. So after we get this, drawing it correctly, then only we flip it. Cuba lipat kertas kamu according to the refraction axis. Okay, flip your paper, fold your paper, and then you flip this and you do this refraction. Horizontal asymptote, when you do refraction, it will come up with vertical. It will come up a vertical asymptote, which is x equals to 0. And your graph here, it should be refract symmetrically. So if you do your refraction correctly, of course your graph will be symmetrical. Alright, so I try to draw as symmetrical as I can. But if you're using your paper, you can draw better than me. Then we label. F inverse is the function that we find just now, which is log 2x. Alright, after you're drawing your graph, make sure you label it. X-axis, y-axis, axis, then function, inverse function, the point that is go through, and the origin. Don't forget your origin. Alright, so this is our question. This is our last question here. So in our last question here, how we going to score this? We have 12 marks here. The first one is how you show this is one-to-one function and get to the domain and range. Secondly, when you want to find inverse, the concept of composite method, and simplifying to get your inverse function, find out the domain of inverse function and range of inverse function. All this is your answer only. Then question C is apply the concept of f inverse, which is equals to x, and get it to the answer of x. For graph, firstly, the function here should be correct. So this is the graph function. Then only we can see your reflection function. Lastly, if you label all correctly, you get another marks. So how many labels you will have here? It will be 1, 2, 3 for the axis, function, inverse function. The intersect here, you get 7. The asymptote here, we get 9. And lastly, we have origin. So label 10 of it. You have 10 labeling completely. You have one more mark on your graph here. Alright, so that's all for this discussion. So hopefully you will study more on that. Alright, so thank you for watching. See you in next video.